And we are back with Chapter 5B. This should be labeled Chapter 5B. We're going to call this Day 11. Just kind of a bad name for that, but we go with it. Solve by factoring. That's the real title to this. So what we're doing is we're now solving. We're going to use factoring as a tool to solve. Solve means to find the value of the variable that makes the statement true. So a couple of things. We first have some synonyms. Solutions to an equation, specifically an equation in one variable. So we have solutions to an equation. They also have multiple names. When we talk about solutions to an equation, we're also talking about, these can also be called zeros, x-intercepts, or roots. These are all synonymous, meaning they all mean the same thing. And when I say solutions to an equation, we're talking about an equation in one variable, a single variable equation. So what type of equations could we mean? Well, we're talking about equations right now that are in the form ax squared plus bx plus c equals 0. This type of equation, where you have a coefficient times an x squared plus another coefficient times an x plus another coefficient, this type is called a quadratic. It comes from the root quadrare, meaning to square, but this is a quadratic. Some of you might have known a quadratic formula. We're not going to get there yet. We're going to solve by factoring first. So let's get to kind of what we mean by this. We have a property. This is an important property called the zero product property. We're going to use this a lot over the next several years. The zero product property. And what the zero product property says is if A times B equals 0, then A equals 0 or B equals 0 or both. One equals 0, the other equals 0, or both. Furthermore, it's a bidirectional condition, so what I can say is if A equals 0 or B equals 0 or both, then AB equals 0. This is the zero product property. Zero meaning the digit, product meaning multiplication. Means anytime you multiply by 0, you get 0. So what I want you to do, we're going to do something a little bit on the side here. I want you to pause the video after I write this, and I want you to evaluate x minus 1 times x minus 2 times x minus 3 all the way up to x minus 97, x minus 98, and x minus 99. What I want you to do is I want you to take this whole thing and I want you to evaluate it when x equals 17. That means I want you to take in 17 and plug it into every single x and multiply it all out. Is that as crazy as it sounds? Oh, absolutely. So go ahead and pause the video right now and try it. Plug it into this whole thing here. 17 minus 1, 17 minus 2. If you got your answer, hopefully you realize something. What happens is you have 17 minus 1, 17 minus 2, 17 minus 3, 17 minus 97, 17 minus 98, 17 minus 99. This may seem like an incredible, crazy product, but somewhere in here we actually have this particular factor, 17 minus 17. 17 minus 17 is 0. So 0 times this whole thing just makes the entire product equal 0. So the whole product is actually equal to 0. So it's a little bit of a trick question, and that's the essence behind the zero product property. We're going to solve some equations now, and to kind of review. To solve, step 1, we're going to write the equation in descending order. That means with the biggest power to the left. And we're going to write it with 0 on one side. This is commonly referred to as the set equal to 0 step. I'm going to put in parentheses, set equal to 0. Step 2. We are going to factor. And step 3, you're going to set each factor equal to 0. So that's the essence behind the zero product property in solving. Let's go ahead and do some. Our example set that we're going to do here is to solve and identify multiple roots. And I'll explain what that means here in a sec. Number 1, I have 2c minus 1 and c plus 4 squared equals 0. Well, the first thing it says is to set it equal to 0, which it is. The second thing is to factor it. This is already factored. You should recognize a factored form. You don't need to factor it anymore because it's already factored. What I can do is I can express it just a little bit more simply. Well, this isn't really simply, but I can pull that c plus 4 apart to make it c plus 4 times c plus 4, just so you can see what's going on here. We really won't write it like that ever. But what this means is that 2c minus 1 is equal to 0, c plus 4 is equal to 0, and another c plus 4 is equal to 0. This is what it means to set each factor equal to 0, because any one of those could have been equal to 0. So we're going to set them all equal to 0, and we're going to solve each one. This would be 2c is equal to 1, or c is equal to 1/2. This is c is equal to negative 4, and this is c is equal to negative 4. These are our solutions, and we're going to express those in set notation. The 1/2 is going to be put there, as is the negative 4. We're going to put this little symbol dr after the negative 4, which stands for double roots, because the negative 4 was repeated. And this is actually our final solution. Let's check another form that is already factored. Number 2. Number 2, I have x minus 2 squared times x squared minus 9 equals 0. Well, the x minus 2 squared, I don't need to worry about the square. That square is going to lead this to be a double root, whatever it comes up with. So really, I just know x minus 2 equals 0, or x is equal to 2. That's my first solution, and that's listed as a double root. Let's examine the rest of this. Well, x squared minus 9 can be factored further. That is x minus 3 times x plus 3, which means that x is equal to 3, or x is equal to negative 3. So those become 2 more solutions. Those are not double roots because they're only repeated once each. But we can put those as a plus or minus 3, and that can close the solution set. My next example, y squared plus 7y equals 18. We now have to have the step of set it equal to 0. So I'm going to say y squared plus 7y minus 18 equals 0. And then we're going to factor this. Two numbers that multiply to negative 18 but add to 7. Well, we're going to put y and y. 18 is 9 and 2, and if I do positive 9 and negative 2, that factors to, okay, that works. Next, I know that y plus 9 is equal to 0, or y is equal to negative 9. I know y minus 2 is also equal to 0, or y is equal to positive 2. And I'll put those in set notation. Negative 9, positive 2. Continuing on, let's go to number 4. 3r squared equals 10r plus 8. And again, I'm going to set it equal to 0. So what I'm going to do is subtract everything on the right side over to the left side. So I have 3r squared minus 10r minus 8 equals 0. Then I'm going to put parentheses around this and factor it. You know, we have 3r and r. 8 can be 4 and 2. 4 times 3 is 12. Minus 2 is 10. So negative 12, positive 2 gives us to negative 10. and this means 3r plus 2 is equal to 0. 3r is equal to negative 2, or r is equal to negative 2/3. And this one, r minus 4 is equal to 0, or r is equal to positive 4. So my solution set is negative 2/3, positive 4. Number 5, we're going to change the wording a little bit. I'm going to say find the zeros of f of x equals x minus 4 cubed minus 4 parentheses 3x minus 16. Okay, well, zeros are x-intercepts, and x-intercepts occur when y equals 0. Well, if you remember from function notation, f of x equals y. F of x acts like y. So what we really need to do here is I just need to take this and rewrite it as 0 is equal to x minus 4 cubed minus 4 times 3x minus 16. So now I need to solve that. Well, we have another complication. This is not factored. And in order to factor it, I'm actually going to have to multiply everything out and then refactor it. So x minus 4 cubed is actually x minus 4 times x minus 4 squared. Just kind of trying to separate that out. Or we can just write it with 3 x minus 4's next to each other. Then minus 12x plus, that would be 64, distributing that part out. So I have to multiply these together. Let's multiply those two, keeping the x minus 4 here in front. And I get x squared minus 8x plus 16. Keeping that part going. Let's clam this up, so x times each of those. I get x cubed minus 8x squared plus 16x. And then let's do the negative 4 times each of those. Negative 4x squared, 32x, be minus 64, then carry down the negative 12x plus 64. Then we have to add some like terms. The x cubed is going to stay. The x squared terms are here, here, and that makes us negative 12x squared. The x terms are here, here, and here. So that's 36x. And the constant terms cancel each other out, 64 and negative 64. Okay, look at what's left. It's very colorful. We can take out a greatest common factor, x. And we have x squared minus 12x plus 36. And that's going to factor as x parentheses. This is going to be x minus 6, or x minus 6 squared. And that's our factored form. So this one would give us x equals 0, and this one gives us x equals 6. Because there's a square that's going to be a double root, we actually call it a double 0 here. So we say the zeros are 0 and 6. And I'll put a parentheses dz for double 0, because that's the context that the question was asked in. Okay, lastly, number 6. Find the domain. And the domain means all possible x's. So what this means, I'm going to give you a function, f of x equals 1 over 3x cubed minus 4x times 2x minus 1. Well, what I want to do is I want to take the denominator of that function, and I want to say this denominator cannot be equal to 0. We can never divide by 0. So I'm going to rewrite that denominator, 3x cubed minus 4x times 2x minus 1. I'm going to say not equal to 0. And then I'm going to proceed to solve this. Well, I have to multiply this out, 3x cubed minus 8x squared plus 4x is not equal to 0. I'm going to factor a greatest common factor out, and I get 3x squared minus 8x plus 4 is not equal to 0. Then I'm going to try to pull out the trinomial. I know it's going to be 3x and x. Then it's probably going to be 2 and 2, because that gives me this 6 and 2, minus minus. Yes, that gives me the negative 8. So what this tells me is that x is not equal to 0. This 3x minus 2 is not equal to 0, so 3x is not equal to 2. where x is not equal to 2/3, and then this is x is not equal to 2. So my domain, we can say all x such that x is not equal to 0, 2/3, or 2. Put braces. What this means is that this is actually a statement saying x can be any real number except for those three, because if I look back up, those are the three real numbers that I could plug into the denominator and have the denominator be equal to 0. So that's why we have to say it cannot equal. And that's it.